All right. Hey, everybody. We have video 7 in the series of homework 10. So for this question, we are going to be determining the validity, aka how true these statements are concerning carbonate CO3 2 minus, the polyatomic. So we're going to draw that Lewis structure for carbonate, and then we're going to answer them questions. We're going to jump straight into the Lewis structures. So we have the three most stable Lewis structures for carbonate shown right here. Then down on the bottom, we have the observed structure. So I didn't show the lone pairs down in this observed structure, but you get the point. They're supposed to be there. Good deal. So if we're going to answer these questions now. First statement says that the bond angles about the central carbon atom are approximately 109 degrees. This is a trigonal planar shape. We have 3 electron groups around our central atom. That's going to give us bond angles of 120. So we know that this first statement is false. Statement number 2, it says that the central carbon atom is sp2 hybridized. If we're an sp2 hybrid, that means we need to mix 3 atomic orbitals. If we're going to mix 3 atomic orbitals, that means we need to have 3 effective pairs around our central atom. And it just so happens that each one of these carbons does in fact have 3 electron groups. Therefore, it's going to mix 3 atomic orbitals, and we're going to have sp2 hybridization for all of these. Okay, so this is going to be a true statement. For number 3, says that there are 3 sigma bonds in carbonate. So we know that a single bond contains 1 sigma, and a double bond contains a sigma and a pi. So if we just count up the total bonds, we get 1 sigma, 2 sigma, 3 sigma, and that becomes a true statement. Statement 4 says that there are 3 resonance structures for CO3. This is also a true statement. We have this double bond. We have 1 double bond and 2 singles. We can resonate that double bond to all 3 locations. They're all equally valid. There's going to be 3 equivalent resonance structures for carbonate. So this is also a true statement. Our last one, this is a little bit of a tough one because we haven't talked about observed structures really at all. So we've discussed the idea of resonance and how certain molecules are able to move electrons through their structure and have these equally valid Lewis structures. This is all fine and good. However, in real life, we don't actually see any of these. We're never going to find a double bond within a carbonate. If you look at any single carbonate in nature out of the billions that exist, all of them are going to look something like this, where instead of seeing 2 single bonds and 1 double bond, all 3 bonds are equivalently lengthed. What happens is this double bond, the electrons, because they can spend time here, here, or here, they average themselves out across the whole molecule, and we get these kind of like 1.33 bonds instead of a single or a double bond. They're somewhere in the middle. What that means, though, is that all these bonds are equivalent strength. If they're equivalent strength, then they're going to be equivalent in length, and this is going to be a true statement. So once you have all of your resonance structures for a given species, you need to consider what the overall observed structure or the resonance hybrid is going to look like when you're making determinations about polarity or about bond length. You don't want to look at one of the individual resonance structures and make a judgment on polarity or bond length, because that's going to give you false information. This structure is not the same as this structure. This structure is an average of these 3 up top. All right, that's going to do it for number 7 for us.